Hello everybody! Does your car have an erratic surging idle like this? Or perhaps does your car also have check engine light codes P1129 and or P0505? Well, in today's video, I'm going to be showing you how to both diagnose and replace all the components associated with these problems, and I'll be demonstrating it on my 2002 Acura TL Type S. And now we're going to purchase some parts. And so first thing we're going to get is some Type 2 coolant from Honda. You can usually get it cheaper at the dealership. And if your car is low on coolant, that can introduce some air into the system and cause some idling issues and other error codes. So the first thing we're going to do is fill our radiator and our coolant reservoir up with coolant. Then we'll start the car, hold the RPMs at 3,000 until the vehicle comes up to full operating temperature. And that should theoretically get rid of any air in the system. And if that was causing any idling issues, it should be resolved immediately. Otherwise, we'll have to go on to more diagnosing and purchasing some parts. So speaking of diagnosing, if you don't have one already, you need an OBD2 scanner. This is essential for diagnosing your car and the problems associated with these codes we have today. This is an Ansel 8310. It's cheap and it certainly gets the job done. You don't need anything fancier than that. We're going to be using this to read codes, erase codes, as well as we're going to be looking at the live data for a couple things. Might sound a little intimidating, but I promise you it's very easy to use. Then we're going to need this MIDIVAC vacuum gun. And this is the ultimate tool that you're going to need to be diagnosing whether or not your idle air control valve is bad or not. And on my car, this was the part that was bad, and this is what you need to diagnose it with. And I had actually purchased a junkyard idle air control valve, and it turned out to be bad, but I didn't know that. And had I purchased this tool and figured out this method sooner, that certainly would have saved a lot of headaches. So highly recommend getting this tool. So now we're going to purchase some actual parts, and there's a bunch of different ways you can go about this. So I'm just going to do one part at a time and give you the options for each part. So first we're going to start with the idle air control valve, the most likely culprit to your problems right now. And you could purchase one brand new from Honda. However, it's going to run you over $300, pretty pricey. And even if you do replace it with a new one, there's still a chance that this might have not been the problem all along. And that'd be a pretty pricey guess just to find out that it didn't fix your problem. So I personally don't recommend it. I recommend getting a junkyard part or a used part off of eBay. And since this part is attached to a throttle body, my first and foremost recommendation would be to get a throttle body from a junkyard. Comes with the throttle body, the throttle position sensor, the map sensor, and the idle air control valve. So it's a one and done deal for about $45 for most junkyards. And so here's a pretty cool website. It's called carpart.com. It's basically a giant database with thousands of junkyards that post all their parts on there. And so we'll just enter our vehicle, 2002 Acura TL. We'll find the part we're looking for, which is a throttle body. Enter your zip code, search. I have a Type S, search. And sometimes you'll find a throttle body, sometimes not. But otherwise, if you can find one, that would be amazing if you can. It doesn't look like there's too many options right now. A couple vehicles down here in some various states. Otherwise, you're not going to find every junkyard part in here. There's a bunch of pull your own part type junkyards. Just look around, see if anyone's got your vehicle, and try pulling one from there. You could also come over to eBay. However, it doesn't look like I'm having much luck for my vehicle finding any throttle bodies on here either. You might have better luck depending on the vehicle that you're repairing. But this is another place you could potentially look for one. If you can't find a throttle body, then what we're going to try and do is purchase the idle air control valve by itself as an alone part. And so we're going to need two part numbers for that. First, we're going to need the actual part number from Honda, which is right here. And we're also going to need the part number on the part itself. Here's the Denso sticker on my idle air control valve. And here's the part number that we need, MX1368001011. And so we can again come on over to eBay, type in that part number from Honda at the top, And there's going to be a lot of aftermarket and fake Honda parts on here. And to weed out a bunch of them, you can come down to the condition and click used. And eventually, with enough scrolling, we'll find one for about 40 bucks, it looks like. And just to ensure that it's the correct part, we'll zoom in on the sticker and we can see MX 136-800-1011. So there we go. We've already found a part for 40 bucks. Otherwise, if you can't find one using the Honda part number, you can also enter the Denso part number. Usually, these are associated with the throttle body they're attached to. And here's another one attached to a Honda Civic, it looks like. Just in case, we'll click on it. And again, we can see there's our part number. So we could purchase this throttle body. As far as finding your part in a junkyard goes, you could also come to the Honda and Acura websites, find your part, go to vehicle fitment, and here's a whole bunch of different Acuras you could potentially find this idle air control valve on. Bunch TLs, MDXs, and CLs. Let's come over to the Honda website, same thing, enter your part number in, go to vehicle fitment, and here's a bunch more. Honda Accords, Odysseys, Pilots. Find this vehicle in a junkyard and you're guaranteed to find your idle air control valve. And if you end up needing to replace your idle air control valve, that means you're going to have to remove the throttle body, in which case, while you're at it, you may as well change out the throttle body gasket. Here's the part number from Honda, if you're purchasing parts from Honda already as is. Otherwise, I might recommend the Felpro brand as an aftermarket option. They're made in the USA, they're cheap, and they work great. However, just be careful because there's a bunch of different options. So just compare and contrast the gasket currently on your vehicle with the one you're purchasing to ensure you're getting the correct part. Here's the one for my car, the Felpro 61319. You can get it for about $427 from Napa. Otherwise, you can also get it on Rock Auto for $156 plus shipping. Or for that matter, you can get one on eBay for $3. Speaking of removing the throttle body, while we're at it, we also may as well clean the throttle body. And so we're going to get some specific throttle body cleaner, not to be confused with carb cleaner. You want to use the right tool for the right job. This has the correct chemical makeup to ensure that you don't damage any sensors or components. So we'll get a bottle of this to clean up any of that carbon deposits on the throttle body. And then I highly recommend getting some scouring pads. These are nicely abrasive while not damaging the actual metal of the throttle body itself. So we'll get a pack of these and clean that throttle body up. The next part you might need to replace is the map sensor. And in a similar fashion, we'll be finding this the same way we did the idle air control valve. However, this is a discontinued product. You can't buy this as a standalone product from Honda unless you buy a $600 throttle body, which I know we're not going to do that. So instead, what we're going to do is we're going to come down and we're going to find our part number. Here it is. And we can go to vehicle fitment. And since this part is located on top of the engine, it's the easiest part to remove in the world. You can get to it in under 5 minutes. You go to any junkyard and you could probably get it for under $5. Here's a list of Acuras that you can find it on. And same thing, come over to the Honda part website, go down to vehicle fitment. And you can find it on a couple more Accords and an Odyssey as well. Otherwise, if you can't find one at a junkyard locally, you can find one on eBay. So again, what we're going to do is we need two part numbers, the Honda part number, and then the part number located on the actual map sensor itself, this TN0798005310 number. So let's go over to eBay. We'll type in the Honda part number first. Doesn't look like there's a lot of options. This one's selling for about $36. In my opinion, that's pretty pricey. So let's try the Denso part number now. We got the Denso TN part number in there, and already I found one for half that price, $16. So that's pretty good if you can't find one at a junkyard. And if you're going to be replacing the map sensor, may as well replace this little O-ring with it. Here's the part number for Honda. Otherwise, you can find these at pretty much any automotive parts store. Here are the dimensions for it. This first number is the inner diameter in millimeters, and the second number is the thickness in millimeters. We're just going to round that to 10 by 2, and we're going to come on over to Napa Auto Parts, 10 by 2 millimeters, 68 cents. Bam. Now, the next few parts are most likely not going to be the problem, but there is still a small chance. The first one's going to be the throttle position sensor. Unfortunately, this part is attached to the throttle body. And so in order to get a new throttle position sensor, you need a whole new throttle body. A new one would cost you $600. And again, I highly recommend not doing that if you can help it. So with that, you'll just have to find a junkyard throttle body, and you'll do so in the same manner that I showed you earlier in the video. Moving on to the next part that might be causing some issues is the PCV valve. This part is also very easily accessible on top of most engines. You simply just disconnect it, you shake it, and if it rattles, it's a good part. If not, it's a bad part. You can find these on many different Hondas and Acuras. You could first just buy one from Acura directly. And in a similar fashion to finding previous parts from junkyards, we're gonna click on the part. We're gonna come down to vehicle fitment. And here's a list of Acuras you can find this part on. Same thing, come over to the Honda website, copy and paste your part number, click vehicle fitment, and you got a couple more Odysseys and Pilots that you can find it on as well. The last part that might be causing some problems, although very unlikely, is the EGR valve. And I don't recommend getting a new one because they're extremely pricey. So again, we're gonna find it in a similar fashion to the previous parts used on eBay or at a junkyard. So let's click our part number. And again, come down to vehicle fitment. And you can find this EGR valve for about $20 from a junkyard on any of these vehicles. Come over to Honda, same thing. Very easy part to find if you need to replace it. You can also type the part number in on eBay. And I've got one here for about $22, it looks like. Now, if all else fails and you've tested all the parts and everything checks out, or for that matter, you've replaced a couple parts and you're still having problems in check engine light codes, you'll probably have to do a smoke test. Now, you could pay somebody $100 some to do a smoke test for you, or you could take that money and put it towards buying your own smoke machine. And this is the one I got. It's the Ansell S3000 Pro. It's a fantastic machine, very high quality. And it goes for about $200 on Amazon. We're going to be using this to check for any vacuum leaks in the system. And if you are getting this smoke machine, you're going to need some mineral oil or baby oil. And if we come down into the advertisement, you can actually see a picture of some Johnson's baby oil. So we're also going to get a bottle of that. This is a pretty big bottle, about 20 ounces. You don't need that much. It's widely available at all convenience stores as well, like Walmart. So get a bottle of that, and that should be everything we need. So why don't we get started? The first thing that we're going to check that can cause idling issues and these check engine light codes is air in the cooling system. So now what we're going to do is try and purge any potential air out of the system. We're going to start by filling the base of the filler neck up with coolant right there. Make sure to use Honda Type 2 coolant, and also do this when the engine is completely cold. You don't want to burn yourself. And then here's the reservoir. We're going to fill it up to the max fill line down there as well. And then we're going to get in the car and we're going to warm it up and hold those RPMs at 3,000 and work out any potential air. I've got my heat turned up to max. And I've got the fan turned up to max. And I'm just holding my RPMs at 3,000 until those fans kick on and see if that fixes anything. Now we just need to remove this manifold cover to reveal a bunch of components that we need to test, starting with the PCV valve, as well as the map sensor, the throttle position sensor, idle air control valve, and the EGR valve. And let's just take this cover off. So now we're going to do some tests on the idle air control valve, and the first one is going to be a vacuum test. And so what we're going to do is we're going to take this vacuum hose that attaches to the air intake tube, and we're going to attach it to a pressure gauge. We're going to start the engine while it's cold, and what we're going to do is we're going to fluctuate the RPMs, and if the gauge moves, that's good. If it does not move as we fluctuate the RPMs, that's bad. So let's give that a test. We're going to fluctuate the RPMs just a little bit. Doesn't need to be a lot. And you can see that the gauge is moving on a cold engine. That's what you want to see. If it does not move, that's a bad sign for your idle air control valve. And then there's one more test we can do in a very similar fashion, and that is we're going to warm up the engine to full operating temperature. And then we're going to, again, take this vacuum line from the air intake tube, attach it to our pressure gauge, and this time when we rev the engine, the valve should not move. We do not want to see that gauge move at all. And if it does move, that again is a sign of a bad idle air control valve. Give it a rev. Okay, it's really not fluctuating, so that's a good sign. Let's do it one more time. All right, and the only reason it's going up is because I'm accelerating and I'm creating a vacuum, so that makes sense, but it is not fluctuating. That's perfect. So we've got a functioning idle air control valve. Something else we can try is tapping on the idle air control valve. Over time, the carbon deposits can build up and get that valve stuck. So by tapping on it with some form of screwdriver, hammer, or whatever, that'll essentially loosen it up a little bit. And then if your idling problems go away, you'll know there's definitely a problem with that idle air control valve. Not a lot of room from here, but from the back, you can definitely see the metal portion of it right there. And so we'll just kind of tap on it when the car's warmed up and as that idling problem's occurring, and we're gonna see if that makes it go away. And we're just gonna tap on it. If the tapping of the idle air control valve doesn't make the surging go away, that's not to say that it isn't a bad component. This just makes the diagnosis a lot faster in case it does make the surging go away. So now we're going to work towards testing the idle air control valve, and it's located at the bottom of this throttle body here. And to get to it, we have to remove this air filter assembly. So we're going to start by removing these two screws right here. And do the same thing for that one. So now we have to remove these two hoses from the air assembly. And now we need to take a 10 millimeter and remove, well, we don't have to remove it, but we have to loosen this hose clamp right here. We can now work towards removing this airbox assembly. Now we have to remove this throttle control valve assembly, and it's ultimately held in by a single nut down there attached to that bracket, as well as there's this hose clamp that's attaching it to the throttle body. And there are 3 electrical connectors you should disconnect. One right here with this wire being attached into this little bracket right there. You got the second one on the side. You got a third one down in there. Then you got 2 pipes you gotta remove. This pipe that's connected to the breather tube, and then you got this pipe connected to the bottom of the throttle assembly. Be careful, this one leaks a little bit of coolant when you remove it. Now we can remove the housing, and it might help to churn it a little bit to get it out of the way of that bracket at the bottom, and then we'll just wiggle it on off. With the throttle control valve assembly removed, now we're going to reconnect all of the hoses and electrical connectors, because if you try and start your car with this pipe disconnected, it's gonna leak coolant everywhere. So reconnect that, reconnect this to the breather tube, and there's this little electrical connector on the bottom, reconnect that. Oh yeah, and also reconnect the map sensor if you disconnected that. With everything out of the way, we have finally reached the inside of the throttle body, and if you look inside, you'll notice there's a little slit. And what we're gonna do is we're gonna start the car, let it warm up, until the erratic idling comes back. And then what we're gonna do is we're gonna take our fingers, we're gonna plug that hole, and if the idling goes down and if the erratic idling goes away, we'll know that this idle control valve on the bottom here is bad. Okay, the car's warmed up and it's idling kind of funny. We're gonna take our finger and we're gonna plug it a little bit. Pretty hot, you gotta be careful so you can see that it went away. So plugging that hole, you can see, made the car idle perfectly. And as soon as I released my finger, it started idling sporadically again. So we can confirm that our idle air control valve is bad and in need of replacing. Now that we know the idle air control valve is bad, it's time to remove it. So we're gonna start by removing the control valve assembly, and then we'll work towards disconnecting everything from the throttle body, including this map sensor, the throttle control valve, the idle air control valve sensor, as well as two hoses, one on top and one on bottom. And the only thing left holding this throttle body on are these two nuts on top, and then there's a bolt down on the bottom there, and then one more on this side as well. And then we should be able to remove the throttle body. And this is the bottom of the throttle body, and here is our idle air control valve, and it's held in by these two screws. We're going to remove those two screws, and then we can take this off. And then we can remove the idle air control valve. There we go. Now we can get everything cleaned up, and then we can take our new gasket, put that in place. And then I'm going to take my new to me idle air control valve, put it in place. Before we put these throttle body components back on the vehicle, now would be a fantastic time to clean them up with some throttle body cleaner. Dirty throttle body is also notoriously known for causing a bunch of rough idle and sporadic idling issues. So we're going to clean out all that carbon junk out of there and make sure to also get the little lip on the actual valve itself to ensure that's creating a proper seal. It is actually a very small but very important tight tolerance. So one thing you can do is, while cleaning it, you can wedge something soft like this rubber handled screwdriver in there, so that way you don't damage the fine metal ends, and you can keep this valve open. And now we're just gonna take our throttle body cleaner, give it a shake, and let's just spray it down. I'll just spray my cloth here as well. And let's start going to town. And we're gonna get that nice and clean, nice and shiny. Obviously, don't forget to clean this edge right here on the valve itself. Probably one of the more important parts to clean. Okay, and after a solid 45 minutes to an hour of scraping away and spraying this throttle body, we got it looking pretty clean. Let's open it up. Not 100% perfect, but it's looking a lot better. We got that lip on the actual valve looking pretty shiny. And the thing about these carbon deposits is you can't just spray your throttle body cleaner on it and it'll just wash away. It's really adhered on there well. So be diligent, be patient, it'll all come off eventually. And also, before you put that throttle body back on, now might be a good time to replace the gasket. If you don't have one, not the end of the world. You can always do it later. I've got the old one taken off and I've got the surfaces all cleaned off. And it was pretty difficult to do, considering that this car is over 20 years old and over 347,000 miles. So I might recommend some specific throttle body gasket remover. Otherwise, what I used was a razor blade and also some of these heavy duty scour pads, just to really get it nice and clean, nice and smooth and shiny on both surfaces. And I went ahead and bought a throttle body gasket as well. And this is just from the brand Fel Pro. Seems to be a reputable brand, and it's also available for purchase from many auto parts stores. And when purchasing a throttle body gasket, make sure you get the correct one. Just for example, my 2002 Acura TL-S, when searching for it, multiple different options came up for the exact same vehicle. So for example, this one has 3 different kind of rectangular cutouts in the middle. So just make sure you match the shape when purchasing this online and compare it to the one on your vehicle. And then we can take the throttle body and we're gonna position it back onto the manifold. There we go. And then we can take each of these nuts and bolts, put them back on, and we're gonna torque them down to 16 foot-pounds in a crisscross X pattern. Now we can reattach the 3 electrical connectors as well as these 3 rubber hoses. And before we put this throttle body valve assembly back on the throttle body, we're gonna clean this up a little bit too. I got this all cleaned up, nice and shiny. And then I took some throttle body cleaner, sprayed a paper towel and just kind of wiped the inside surface. And then took some silicone paste, dabbed it all around, spread it with my finger, let it sit for a minute. Took a nice clean paper towel and cleaned it up. You can see it's nice and shiny clean in there. Yeah, there we go, nice and clean. So that should create a good seal. And now we're gonna put this assembly back on the car. I cleaned up the oil dipstick as well, again with some throttle body cleaner just on a paper towel, wiped the old dirt and oil off, gave it a little coating of silicone paste, let it sit for a minute, wiped it with a clean paper towel. Now we can reinstall the throttle control valve assembly. And might want to install it at a 45-degree angle so you can get past that bracket. And just kind of wiggle it back in place onto the throttle body. And we can turn it clockwise. There we go. After loosely sliding that traction control valve on, next we'll install that little bracket bolt down there and we'll torque it to 16 foot-pounds. Then we can reattach that electrical connector deep down in there, as well as this throttle position sensor connector. And then there's this hose on the bottom right here. Reconnected that. Now we can take this air filter housing and we can maneuver this back in place. And then we can put that cover back on. Now it's time to take the car for a test drive. We'll bring it back and see if that idle is fixed and if that check engine light has officially gone away. Before we go for a drive, we're just gonna take our OBD2 scanner and we're going to erase those trouble codes. So that way we aren't getting repeat codes and we know if something new comes up. Just got back from a couple-mile drive and it is not surging anymore. Full operating temperature, no surge. Nice. The MAP is below 43. Let's just make sure we don't have any pending codes. No stored codes. And no pending codes. Oh, we fixed it, everybody. So now we're going to do an electrical test on, more specifically, the wiring leading to the map sensor. And so we need to find the power wire, the ground wire, and the signal wire. So we've got it, for starters, set to volts. I'm just gonna put one lead on the negative terminal of my battery, and I've got the power to the car on, and we're just going to test each of these leads. This one reading 5 volts is the power, and that's what it should be reading, about 5 volts, so that's perfect. How about this ground wire? It's got a little bit of some, but that's not our signal wire, so that must mean this is the signal wire. And it should read at about 3 volts. So there we go. Number 1 is power, 2 is ground, and 3 is signal. But just in case, we're gonna check for continuity on that ground wire, and it should make a noise. I don't think my paper clip's in there good, but you can hear it's beeping, so that is our ground wire. Next, what we're gonna do is we're going to start the vehicle, and we're going to test between the ground on our battery as well as the power to number 1, and that should stay at 5. And then we're going to test between the ground on the battery and our signal wire, and that should be around 1.5 volts at idle. So let's test that power wire again. Should be at 5 still. Very good. Let's test the signal wire. Perfect, we're at 1.4. Okay, now I've got some alligator clips on my wires for this next part. We're going to be checking the signal voltage during the throttle fluctuations. I don't have enough hands, so we'll start the car and I'll give it a quick flick and see if the voltage jumps up to above 3, and then if it falls down to below 1. So let's give that a go. So we're at about 1.5, so that's good. Let's give it a quick flick. So it didn't necessarily jump above 3, but nonetheless, we did see the voltage increase. And then when we quickly let it go, we also saw it drop below 1. So we can ensure that the map sense is working. Now here's one other test you can do to ensure that your map sensor is good or not. You can come in the vehicle after the car's warmed up, hook up your OBD2 sensor, and we're going to go to the live data. And this is just a cheap OBD2 scanner, and an old one at that. So you can buy any scanner and you'll be able to do this. We're just gonna come down the options menu a little bit, and we're gonna look for this map diagram here. It's measured in kPa, and it should be about 43, preferably less. And you can see mine's hovering right at about 45, 46. So it's just above it, but nonetheless, that should be okay. Now we're just gonna take this electrical connector, squeeze a little pinch tab, and disconnect it. There we go. And then we're gonna take a Phillips screwdriver, and we're gonna remove these 2 screws. And then the map sensor should lift right off. And before we put that map sensor back on, now would be a good time to replace this O-ring. Also, we'll get a little pick tool under there. There we go. And here's my nice new one. And now we're gonna take our new sensor. Here's our new one. We're gonna just put it right back in place. And then we can reconnect our electrical connector. So now we're gonna do a throttle position test on this sensor right here. And there are 3 tests we can do. We can do 2 ohm tests and then a scan tool test. And for the ease of filming purposes, I'll be using my extra throttle body here. And what we're gonna do is we're gonna do a test between prongs 1 and 2, and then 2 and 3. For prongs 1 and 2, we should get about 500 to 900 ohms, and between 2 and 3, we should get about 4,500 ohms. If it's a little out of range, it's okay, just as long as it's close in the grand scheme of all things. So now what we're going to do is a scan tool test. And what we're gonna do is we're going to come down to live data, and then we are going to scroll until we find TP percentage. That stands for throttle position, and it gives it in a percentage. And with our foot off of the accelerator pedal down there, we want this number to read about 10%. And then as we push our pedal all the way down to the floor, we want this then to go up to about 90%. So let's do that now. I'm going to press down, and we are at about 90%. And as we gradually let off, we should see it gradually go down as well, all the way back down to about 10%. So perfect, our throttle position sensor is working just fine. If you end up needing to replace your throttle position sensor, you'll unfortunately need to replace the entire throttle body as it's permanently attached to it, and you can watch how to do that earlier in the video. Another potential problem that could cause the surging idle problems, although not likely, is the PCV valve. It's simply located in the back of the engine bay right here. All we're going to do is just pull it straight up and out. There we go. Sometimes it might be a little oily. That's natural because it's right in the engine. And the simple way to test it is to shake it. Hear that little metallic ball in there, that little valve? That's what you want to hear. If you don't hear that at all, that means that valve is stuck and you should replace your PCV valve. On to the next probable cause, the EGR valve. Sometimes that can get gunked up with carbon deposits in its ports. And so we're simply going to remove it and clean it up. It's held in by an electrical connector and 2 nuts. So here's the EGR valve. Really doesn't look like it's caked up with any carbon deposits or anything. Might be a little rusty in some aspects, but it otherwise looks pretty good. So looking down there, oops. Same thing, doesn't look like it's clogged with carbon deposits. So since we have it off, we're just gonna do a couple continuity, ohm, and voltage tests. Now we're gonna do a simple ohm test. We're gonna first start with prongs 1 and 2. And it should be less than 100,000. Right now we're getting 1.5 thousand, so that's perfect. Then we're gonna do an ohm test between prongs 1 and 3. And it should also be less than 100,000. And you can see we're getting 4.4 thousand. So that is also good. So I've got my positive on prong number 4 and my negative on prong number 6 at the bottom. And we're just gonna do a quick little piston test, see if it's working. I'll put the red on there, negative here. And you can see that it was moving in and out just fine. So we know that's good. And before we put it back on, we're just gonna make sure that the gasket is in good condition. I've got it all cleaned up, so that should create a good seal. And also just clean off the mating surface that it will be going onto as well. And then we're gonna torque these bolts down to 16 foot-pounds. Next, we're going to test our motor mounts for a vacuum test. You can see there's a vacuum line coming out of the motor mount right there. And if you follow them, eventually they'll both meet at a T connector. You can kind of see there's the other line right there. And it connects at a T connector right down there. And so we're gonna follow the line that goes up and around this line right here. It goes up and it connects to this little actuator right here. And so we're gonna disconnect this line from the actuator and we're gonna do a simple little vacuum test. I have that motor mount vacuum line attached to my little vacuum pump here. And really simple, we're just gonna pump it up and see if it holds vacuum. We do not want that little needle to gradually be decreasing, so let's pump it up. And it's holding perfectly still for the most part. That's great. And I'm gonna be checking for some vacuum leaks. I've got it hooked up to my air intake right here. There's a big old cone, just fits. And we're gonna check the intake. And there's also the brake booster line. It's this big thick line right here. Connects to the back. Really hard to see down there. Connects basically to the back of the firewall. And we're gonna connect our evap machine up to these two lines, see if we can find any smoke coming out of any leaky ports. And I think I found at least one leak anyways. So this was right here. Any second now. Kind of see the smoke billowing up. Really coming out of that port right there. And I've got it hooked up to the brake booster line, as well as I've got the other end of the intake still plugged up. I've also got this little line plugged as well, just in case. And my leak still appears to be coming from that same spot, right down there. And also after flipping it upside down, I'm not seeing a leak coming from there anymore specifically. I think it's just a poor seal around the actual rubber part to the throttle body itself. You can see smokes kind of billowing out from all angles immediately around it. And yeah, just a tiny little leak right there. And I additionally think I found a leak coming from this EGR valve. My oil dipstick has some smoke leaking out of it. And there we have it, everybody. We are all finished. Turns out my idle air control valve was bad all along. I had purchased a junkyard part, put it on, and the problems persisted. But had I known about the vacuum test all along, that would have saved me a lot of time and a lot of headache. I ended up buying a third junkyard idle air control valve, and all the problems went away immediately. So I certainly hope you guys find this video helpful and insightful. And if you did, why don't you go ahead and consider smashing that like button. Certainly helps me out a lot. And consider subscribing as well, where you're going to find a bunch of other videos on my channel showing you how to fix your car just like this one. Also, feel free to check out the description. There's going to be a bunch of other links, info, timestamps, and whatnot. And feel free to leave a comment. I'm pretty good at getting back to people there as well. So as always, thanks for watching. Have a great day and take care.